So, hello dear students, please mark your attendance. So, in this today's lecture, we are going to study the applications of semi-empirical mass formula, and we will also solve some of the important numerical problems which can come in competition exams related to this semi-empirical mass formula. In this today's lecture, we are going to study. So, ਜਿਸ ਤਰ੍ਹਾਂ ਕਿ ਆਪਾਂ ਬਾਈਂਡਿੰਗ એનર્ਜੀ ਦਾ ਜਿਹੜਾ ਐਕਸਪ੍ਰੈਸ਼ਨ ਆ ਉਹਨੂੰ ਆਪਾਂ ਪਿਛਲੇ ਜਿਹੜਾ ਲੈਕਚਰ ਆ ਉਹਦੇ ਵਿੱਚ ਡਿਸਕਸ ਕਰ ਲਿਆ ਸੀ ਐਂਡ ਵੀ ਹੈਵ ਫਾਈਂਡ ਆਊਟ the total binding energy of the nucleus, which is sum of 5 different type of energies which are present in the nucleus, and the relation which we have derived, that is so binding energy or we can also call it as the binding fraction. FB, in some books it is written binding energy in this form. So it is sum of volume energy, surface energy, Coulomb energy, z minus 1 over a over it is 2 by 3 minus asymmetry energy a minus 2z square over a square plus pairing energy. So this is the expression which we have derived for binding energy. So just a minute. Okay. Now, what are the various applications which we can derive from this binding energy formula? So first application, we can determine the nuclear charge radius. So this we can determine from the Coulomb energy constant. So that is AC, which is equal to 3 by 5 E square over 4 pi epsilon naught R naught A1 by 3, and from this we can find out the value of this Coulomb energy constant for different radius, and if we choose this Coulomb radius, it is coming out to be 0.69 MeV for radius value which is of the order of 1.2 femtometer. So the value of this Coulomb energy constant, it is dependent upon the nuclear radius and it gets changed so with the change in nuclear radius. So second, we can find out the stability of nuclei against beta decay. So through this we can find out which of the given atomic nuclei which is having what are its stable isobar, so how many isotopes it have. So mass of nucleus we all know that is equal to Z mass of proton plus A minus Z times mass of neutron minus binding energy over C square. So if we put the value of this binding energy, so then this mass of nucleus, it comes out to be A minus Z times mass of neutron minus 1 over C square. This is equal to A naught A, that is the volume energy, AS, A2 by 3, this is the surface energy, Z minus 1 over A1 by 3. So this is the term which is coming through Coulomb energy minus asymmetry energy over A plus minus pairing energy term. So this is the value of the total binding energy and this formula is known as the semi-empirical mass formula. Now from this equation number 1, so if we try to derive its connection with the mass parabola, so if I assume that Fa is equal to A times Mn minus volume energy constant plus asymmetry energy constant As A by 2. So these are the assumption in order to derive a shortcut to the formula. Through this we can find out the stable isobars, and P I have assumed it is 4 times An minus mass of, here An or As, so they are the same. So in some books it is written as An, so that is the asymmetry term. So I will write here As, so Mn minus Mp, and Q is 1 over A AC 2 by 3 plus 4 times As. So if we put these values Fa, P and Q in our equation number 1, then our equation is looking like in this form, that is equal to Fa plus Pz plus Qz square. So this is the equation of parabola for given mass number, and this equation is also known as the mass parabola equation. Now in order to find out the stable isobars, so if I take the differentiation of this term with respect to z, so this equation becomes P plus 2qz, so that is equal to 0. So that is when the value of z is equal to z times a, that is for a stable isobar. So what we get is, so we get from here the atomic number of a nuclei which is having the most stable nuclei for their particular nucleus, so it comes out to be minus p over 2q. Now putting the value of p and q, so 4 times as times a over 2 times Coulomb energy term plus asymmetry term. So when we put all these constant, asymmetry constant, Coulomb constant, and from that we derive a relation between z and a, that is a over 1.98 plus 0.015 times A 2 by 3. And this is very important relation to find out the most stable isobar, or we can use this equation to find out the maximum binding energy which is being emitted for that particular reaction. So can you hear me? Just confirm, because my mobile fell down and I think the connection was cut off. So please confirm. So then I will start from here. So from this, if we try to plot this equation, so that is the mass number with respect to Z. So it is something like a parabola, and the most stable isobar, so they are present within the center, and the isobar to the left. So this is the position where we can find out the most stable isobar. So this region is also known as stable isomerism. So nuclear isomerism we ਆਪਾਂ ਇਹਨੂੰ ਕਹਿ ਦਿੰਦੇ ਹਾਂ. So the isobar to the left of the stable one, so they decay by beta minus emission, and the nuclei which are present to the right, so isobar to the right of the stable isobar, they decay by positron or beta plus emission. So you can say, so this side, so there is the nuclei which are present, so they will decay probably beta minus or electron emission. So this side, so there is probably the positron emission. So nucleus are present which will emit positive nuclei. So let us try to do some numerical related to this. So first question is, establish the relation A is equal to 2 times Z for lighter nuclei using semi-empirical mass formula. So what is given? Coulomb energy is given 0.71 MeV. Asymmetry energy it is given 22.7 MeV, where mass of proton, that is 1.0078 times atomic mass unit, while mass of neutron, it is 1.0086 AMU. Now for odd nuclei, the pairing energy term is 0, so our total mass energy term, this will become Z mh minus A minus Z mn minus 1 over c square times the binding energy. So this is the pairing energy. So for odd nuclei, so this pairing energy term, it is equal to 0, and the mass of most stable nucleus, or you can say the most stable isobar. So if we do curly m by curly z is equal to 0, so then this equation, this becomes mh minus mn c square plus 2 times Coulomb energy term minus 4 times the asymmetry term. So this comes out to be 0. So solving for this, so this becomes where Mn is representing the mass of neutron. So this comes out to be so I will not do the whole derivation, so just write down the equation 1 plus Mn minus Mh c square over 4 times An just a minute. Over 1 plus AC over 4 times An the power 2 by 3. So when we put all these energy constants and putting the value of AC over 4 times asymmetry term, so which comes out to be 0.078 Mn minus Mh c square over 4 times As, so that is 0.082. So what we derive is the same equation which we have derived from the mass parabola, so that is a by 2 1 plus 0.082 over 1 plus 0.0078 times a 2 by 3. So for lighter nuclei, so where the value of A, this is very small, so Z comes out to be A by 2. or otherwise this expression, so which we have written in our previous equation, you can use this equation for heavier nuclei. So that is A over 1.98 plus 0.015 A 2 by 3. So in some books it is 1.98, it is written approximately equal to 2 plus 0.015 A 2 by 3. So you can use this relation for heavier nuclei, and this is the relation for lighter nuclei in order to find the most stable isobar. So next question related to this is, using the semi-empirical mass formula, explain which is the most stable among 2 helium 5, 2 beryllium 6 and 3 helium 6. So which is the most stable isobar? So using the relation A over 2 plus 0.015 times 2 by 3, so we can put the values of AC and AN and for lighter nuclei, so we have derived, so this is Z is equal to A by 2. So among these three, so in this Z is 2, A is 5, Z is 2, A is 6, here Z is 2 and Z is 3 and A is 6. So which is following this condition, so among these three lighter nuclei, lithium 3,6 is the most stable isobar. So this is the most stable isobar. Now sometimes there is a question, so two isotopes are given and you have to find which is the stable isotope. So question is, which nuclei you would expect to be more stable? So one is 3 lithium 7 or 3 lithium 8. Second is 4 beryllium 9 or 4 beryllium 10. ਹੁਣ ਇੱਥੇ ਤੁਸੀਂ ਦੇਖੋ ਕਿ ਚਾਹੇ ਇਹ ਜਿਹੜੇ ਆ ਇਹ ਲਾਈਟਰ ਨਿਊਕਲੀਆਈ ਆ, ਬਟ Z is equal to A by 2, that is ਕੋਈ ਵੀ ਜਿਹੜਾ ਉਹਨੂੰ ਸੈਟੀਸਫਾਈ ਨਹੀਂ ਕਰ ਰਿਹਾ. ਸੋ ਜੇ ਇਦਾਂ ਦਾ ਕੁਐਸਚਨ ਹੋਏ, then we have to use our standard formula, that is A over 2 plus 0.015 times A 2 by 3 in order to calculate the most stable nuclei. ਹੁਣ पहले केस की जे आपां गल करिए सो इहदे विच z is 3 and a is 7 सो साडे कोल ये इक्वेशन की बन जाएगी so we can find out the z stable so za we have to find so which is more stable so a is 7 over 2 plus 0.015 7 the power 2 by 3 so this comes out to be 2 plus 0.055 so that is 7 over 2.055 which is 3.4 so ਇਹਦੀ ਜਿਹੜੀ ZA ਦੀ ਜਿਹੜੀ value ਆ ਰਹੀ ਆ that is 3.4 and let us calculate for this so ZA this comes out to be 8 over 2 plus 0.015 times 8 2 by 3 and when you calculate it so it is coming 3.88 so ਇਹਦੀ ਜਿਹੜੀ value ਆ ਰਹੀ ਆ so that is ZA ਦੀ that is 3.88 ਹੁਣ ਇਸ ਕੇਸ ਦੇ ਵਿੱਚ ਸਾਨੂੰ ਦਿੱਤਾ Z ਕੀ ਆ ਸੋ Z ਦੀ ਸਾਨੂੰ ਵੈਲਿਊ ਜਿਹੜੀ ਆ ਉਹ 3 ਦਿੱਤੀ ਹੋਈ ਆ now you can check which is more closer to 3 ਕਿ 3 ਦੇ ਲਾਗੇ ਜਿਹੜਾ ਆ ਉਹ ਕਿਹੜਾ ਨਿਊਕਲੀਅਸ ਆ so 3.4 is more closer to 3 as compared to 3.88 so ਇਹਦਾ ਮਤਲਬ ਕੀ ਆ कि 3 lithium 7 so this is more stable so this is more stable as compared to 3 lithium 8 so ਇਸੇ ਤਰ੍ਹਾਂ ਹੀ ਤੁਸੀਂ ਜਿਹੜਾ ਹੈ ਇਹ ਬਰੀਲੀਅਮ ਦਾ ਜਿਹੜਾ ਹੈ ਉਹਨੂੰ ਵੀ ਸੋਲਵ ਕਰ ਸਕਦੇ ਹੋ so 4 beryllium 9 and 4 beryllium 10 so here ZA that is equal to 9 over 2 plus 0.015 2 by 3 so that comes out to be 9 over 2.065 that is 4.36 and for this so ZA is 10 over 2 plus 0.015 into 10 2 by 3 so that comes out to be 10 over 2.067 so that is 4.80 so again 4.36 it is more closer to 4 क्योंकि सानू जिहड़ा एटॉमिक नंबर है वो 4 दिता होया so 4.36 is more stable among 4 beryllium 10 so let us do one more question related to this so next question is for what elements should stable isobar exist for A that is 97 कि A97 ਦਾ ਜਿਹੜਾ ਸਭ ਤੋਂ ਸਟੇਬਲ ਆਈਸੋਬਾਰ ਆ ਉਹ ਕੀ ਹੋਏਗਾ ਹੁਣ ਇਸ ਕੇਸ ਦੇ ਵਿੱਚ ਸਾਡੇ ਕੋਲ ਜਿਹੜੀ ਇਕੁਏਸ਼ਨ बनती है। So you can calculate ZA in the similar way, that is A over 1.98 plus 0.015 A2 by 3, and you can calculate the value of Z from here and it comes out to be 42.1. So from this you can tell that the most stable isobar for atomic mass 97 is molybdenum. So whose atomic number is 42. So similarly you can calculate the most stable isobar of any other nuclei which are being asked. Now some of the competition exam questions so which can come, ਹੁਣ ਇਸ ਕੇਸ ਦੇ ਵਿੱਚ question ਕੀ ਹੈ, in the semi-empirical mass formula the volume, surface, coulomb and pairing contribution to binding energy of a nucleus, so they are given. So what is given? So various values of the volume energy term, the surface energy term, its relation, the coulomb energy term and the pairing energy term. ਹੁਣ ਸਾਡੇ ਕੋਲ ਜਿਹੜਾ binding energy ਦਾ formula है, so that is equal to AVA minus A symmetry 2 by 3 minus coulomb energy Z minus 1 over A 1 by 3 minus asymmetry term A minus 2Z square over A plus pairing energy, so that is A 3 by 4. ਹੁਣ ਇਸ ਰਿਲੇਸ਼ਨ ਤੋਂ ਤੁਸੀਂ ਆਈਡੀਆ ਲਗਾ ਸਕਦੇ ਹੋ ਕਿ it is directly proportional, so volume is directly proportional to A. ਸੋ ਸਾਰਿਆਂ ਦੇ ਵਿੱਚ ਜਿਹੜਾ ਆ ਤਿੰਨ ਆਪਸ਼ਨਸ 'ਚ A ਦਿੱਤਾ ਹੋਇਆ, ਚੌਥੀ ਆਪਸ਼ਨ 'ਚ A ਸਕੁਅਰ ਦਿੱਤਾ ਹੋਇਆ, ਸੋ ਇਹਦਾ ਮਤਲਬ A ਆਪਸ਼ਨ ਤੇ ਜਿਹੜੀ ਆ ਇਹ ਹੋ ਨਹੀਂ ਸਕਦੀ। ਦੂਸਰੀ ਆਪਾਂ ਸਰਫੇਸ એનર્ਜੀ ਦੀ ਗੱਲ ਕਰੀਏ, ਸੋ ਇਫ ਯੂਜ਼ਿੰਗ ਦਿਸ ਰਿਲੇਸ਼ਨ, ਸੋ ਸਰਫੇਸ એનર્ਜੀ ਜਿਹੜੀ ਆ ਇਟ ਇਜ਼ ਡਾਇਰੈਕਟਲੀ ਪ੍ਰੋਪੋਰਸ਼ਨਲ ਟੂ A2 by 3। ਹੁਣ A2 by 3 ਜਿਹੜਾ ਆ ਉਹ ਕਿਹਦੇ 'ਚ ਦਿੱਤਾ ਹੋਇਆ? ਪਹਿਲੀ ਆਪਸ਼ਨ 'ਚ A2 by 3 ਦਿੱਤਾ ਹੋਇਆ, ਦੂਸਰੀ 'ਚ A1 by 3 ਦਿੱਤਾ ਹੋਇਆ, ਤੀਸਰੀ 'ਚ ਜਿਹੜਾ ਆ A minus 2 by 3 ਦਿੱਤਾ ਹੋਇਆ। ਸੋ ਇਹਦੇ ਤੋਂ ਤੁਸੀਂ ਦੇਖ ਸਕਦੇ ਹੋ ਕਿ ਜਿਹੜੀ ਸਰਫੇਸ એનર્ਜੀ ਟਰਮ ਆ ਉਹ ਕਿਹਦੇ 'ਚ ਸਹੀ ਆ ਰਹੀ ਆ, ਸੋ that is option A। तीसरी you can also compare the coulomb energy, so coulomb energy ਜਿਹੜੀ ਆ using this relation, so coulomb energy it is inversely proportional to A1 by 3, so ਇਹਦਾ ਮਤਲਬ ਕੀ ਆ, it is proportional to minus of A minus of 1 by 3, and pairing energy ਤੋਂ ਵੀ ਤੁਸੀਂ ਜਿਹੜਾ ਆ ਉਹ ਦੇਖ ਸਕਦੇ ਹੋ using this relation that pairing energy is directly proportional to A minus 3 by 4। so ਕਿਹੜੀਆਂ ਜਿਹੜੀਆਂ options ਆ ਉਹ satisfy ਕਰ ਰਹੀਆਂ ਇਸ condition ਨੂੰ, so option A is the correct option। so you need to remember this equation, so ਕੁਝ ਵੀ ਜਿਹੜਾ ਆ ਇਦਾਂ ਦੇ ਨਾਲ ਜਿਹੜਾ ਇਸ equation ਦੇ ਨਾਲ related ਜਿਹੜਾ ਆ ਪੁੱਛਿਆ ਜਾ ਸਕਦਾ ਹੈ। so next question is also related to this semi-empirical mass formula। question की है, a nucleus may be modeled as a drop of liquid consisting of the nucleons. In this model the dominant contribution to nuclear binding energy is from the volume, which is proportional to A, the total number of nucleons. The two important subdominant contributions from the surface tension, which is related with the surface energy, and the Coulomb repulsion of the protons, they are proportional to. So again, so ਸਾਨੂੰ ਜਿਹੜਾ ਆ ਉਹ ਬਾਈਂਡਿੰਗ એનર્ਜੀ ਜਿਹੜੀ ਆ ਉਹਦਾ ਐਕਸਪ੍ਰੈਸ਼ਨ ਪਤਾ ਹੋਣਾ ਚਾਹੀਦਾ AVA minus asymmetry times mass 2/3 minus A Coulomb energy, which is Z minus 1 over A 1/3 minus asymmetry energy, which is A minus 2Z square over A plus minus pairing energy, which is AP over 3/4. ਹੁਣ ਸਾਡੇ ਕੋਲ ਜਿਹੜਾ ਪੁੱਛਿਆ ਹੋਇਆ ਉਹਨਾਂ ਨੇ surface tension, which is the term related with surface energy, and Coulomb repulsion, so that is the Coulomb energy term, ਕਿ ਉਹ ਜਿਹੜੀਆਂ ਆ ਉਹਨਾਂ ਦਾ ਰਿਲੇਸ਼ਨ ਕੀ ਹੈ। ਸੋ ਤੁਸੀਂ ਜਿਹੜਾ ਆ surface tension ਜਿਹੜੀ binding energy related with this surface tension, that is equal to AS time 2/3. So this binding energy related with surface tension is directly proportional to 2/3. So 2/3 option ਕਿਹਦੇ ਚ ਹੈ? option A ਤੇ option B ਦੇ ਵਿੱਚ ਜਿਹੜੀ 2/3 ਹੈ, C ਦੇ ਵਿੱਚ 1/3. so ਇਹਦਾ ਮਤਲਬ C ਵੀ option ਨਹੀਂ ਹੋ ਸਕਦੀ, D ਵੀ ਨਹੀਂ ਹੋ ਸਕਦੀ। Now let us check this Coulomb repulsion term. So that is Z square over A 1/3. ਹੁਣ ਜਦੋਂ ਆਪਾਂ ਇਹਨੂੰ open ਕਰਦੇ ਹਾਂ, so this becomes Z square minus Z. So this is directly proportional to Z square over A 1/3. So that is option B is the correct option for this question. So next question related to this is the binding energy expression that is given, where n is equal to A minus Z is the neutron number. The value of Z for this most stable isobar, so there are only two options which are given. So let me check. So what is the complete question? So because only two options are given, okay, so let's do another question, because options are not given for this question and I have to find it, so it will take some extra time. So okay, no, okay, all the options are given, A, B, C and D, so everything is given. Okay, so I thought so there are no two options. So we have to find the most stable isobar for this question. So how we can do? So we can do using the same method, BA, that is given. So we will take the derivative of this with respect to 0. So for most stable nucleus. So when we take the derivative of this expression, so this first term becomes 0, second there is no any Z value, this becomes 0, minus 3/4 Z square, so this comes 2 into 3/4, that is equal to 6/4 Z A minus 1/3 plus 30 over A n minus Z, we can also write it A minus 2Z, so this comes out to be 2 into A minus 2Z over A. So this equation we can write something like A minus 2Z square over A. So 2 comes ahead and here there is minus of 2. So this is equal to 0, and while solving what we get is ZA minus 1 by 3 over 4 plus 20 over A minus 2Z, that is equal to 0. So this becomes ZA minus 1 by 3 over 4 plus 20 minus 40Z over A, that is equal to 0. So ZA minus 1 by 3 over 4 minus 40Z over A, that is equal to minus of 20. So this becomes 40 Z over A if I take constant, so that is 1 minus 1 over 160 A minus 2 by 3, that is equal to minus 20. So from this we can find Z is equal to A by 2, 1 minus A 2 by 3 over 160 inverse. So this is the relation between Z and A so far the given binding energy. So you can check. So here option A is the correct option. ਹੁਣ ਜਿਹੜਾ ਆਪਾਂ ਰਿਲੇਸ਼ਨ ਡਰਾਈਵ ਕੀਤਾ ਆ ਉਹ ਤੇ ਸੀ ਕਿ ਆਪਾਂ ਜੇ ਸਾਨੂੰ ਕੋਈ ਵੀ ਵੈਲਿਊ ਜਿਹੜੀ ਆ ਉਹ ਨਹੀਂ ਦਿੱਤੀ ਹੋਈ, ਜੇ ਸਾਨੂੰ ਕੋਈ ਪਾਰਟਿਕੂਲਰ ਬਾਈਂਡਿੰਗ એનર્ਜੀ ਦੀ ਜਿਹੜੀ ਇਕੁਏਸ਼ਨ ਆ ਜੇ ਸਾਨੂੰ ਉਹ ਦਿੱਤੀ ਹੋਈ ਆ, then we have to use that equation in order to find the correct derivation for the most stable isobar. ਹੁਣ ਇੱਥੇ ਇਹ ਨਹੀਂ ਹੈ ਕਿ ਤੁਸੀਂ ਉਹ ਪੁਰਾਣੀ ਇਕੁਏਸ਼ਨ ਜਿਹੜੀ ਆ ਜਿਹੜਾ ਫਾਰਮੂਲਾ ਆਪਾਂ ਫਾਈਂਡ ਆਊਟ ਕੀਤਾ ਹੈ Z is equal to what is that formula? So just a minute. So that is A over, okay, A over 2 plus 0.015 A the 2 by 3. ਹੁਣ ਇੱਥੇ ਸਾਨੂੰ ਜਿਹੜੀ ਆ ਉਹ ਇੱਕ ਇਕੁਏਸ਼ਨ ਦਿੱਤੀ ਹੋਈ ਆ, so we have to again find out to solve this equation and then we have to find the answer. So this is the question of NET June 2013 examination. So let us do one more question related to this, and this is the question in CSIR 2014 examination. Now question is, if the binding energy of the nucleus is given by this expression where volume constant, surface constant, asymmetry constant and the Coulomb constant they are given, then find out the most stable isobar for a nucleus with A is equal to 216. So I will write here the equation. So for a most stable isobar, curly B over curly Z, it should be equal to 0. And when I do this, so this equation becomes 0, first term 0, second term is 0 minus asymmetry term 2 into 2Z minus A. So this comes ahead over A into 2 minus Coulomb energy term Z over A 1 by 3. So when I take the derivative of this, Now let us put all those values. So this is equal to 0. So when I put ਕਿਹੜੀ ਵੈਲਿਊ ਸਾਨੂੰ ਚਾਹੀਦੀ ਹੈ, ਇੱਕ ਤੇ ਚਾਹੀਦੀ ਸਾਨੂੰ asymmetry constant ਦੀ ਵੈਲਿਊ ਤੇ ਇੱਕ ਚਾਹੀਦੀ ਸਾਨੂੰ ਕੂਲਮ એનર્ਜੀ constant ਦੀ ਵੈਲਿਊ। ਸੋ asymmetry ਦੀ ਜਿਹੜੀ ਵੈਲਿਊ ਆ that is equal to 24 mega electron volt and coulomb energy constant that is 0.75 mega electron volt. So this 2 and 2 it get 4, so 4 गुना 24, so that is equal to 96 2z over a minus 1 plus 2 times 0.75 that is equal to 1.5 z over a 1 by 3 that is equal to 0. Now putting the value of a, so a is 216 that is given, so this equation becomes 96 into 2 that is 192 times z over 216 minus 96, which I move to the right hand side, it become plus 96 plus 1.5 z over 216 the power 1 over 3. So this comes out to be get cancelled 8 over 9z plus 1.5 z over 6 that is equal to 96, and when I solve this, so that is 8 over 9 plus 1 over 4z that is equal to 96. So taking the LCM of this, that is 36, 9 चौके 36 8 चौका 32 plus 9 z that is equal to 96. So z comes out to be 96 into 36 over 41. So when you solve it, so it is 84.29. So z is more or less close to 84. So z is equal to 84 is the correct option. कि जेड़ा 84 एटॉमिक नंबर वाला जेड़ा न्यूक्लियस होएगा, so 216 mass number ਦੇ ਲਈ that is the most stable isobar. So this is the last question of today's lecture. So this question is, of the nuclei of mass number A125, the binding energy calculated from the liquid drop model are, ਉਹਦੇ constant ਦਿੱਤੇ ਹੋਏ ਸਾਨੂੰ ਕੂਲਮ એનર્ਜੀ constant ਦਿੱਤਾ ਹੋਇਆ ਤੇ asymmetry energy constant ਦਿੱਤਾ ਹੋਇਆ that is 0.7 mega electron volt and asymmetry constant is 22.5 mega electron volt. So ਇੱਥੇ ਮੈਂ ਇੱਕ ਗੱਲ ਕਹਿਣੀ ਚਾਹਨਾ ਕਿ ਜੇ ਤੁਹਾਨੂੰ constants ਦਿੱਤੇ ਹੈਗੇ ਆ, then you have to use the full equation of binding energy and then you have to derive the formula of curly b over curly z. ਜੇ ਤੁਹਾਨੂੰ ਉਹ constants ਦੀ value ਨਹੀਂ ਦਿੱਤੀ ਹੋਈ, ਸੋ ਉਸ ਕੇਸ ਦੇ ਵਿੱਚ ਤੁਸੀਂ ਜਿਹੜੀ ਆ ਉਹ equation use ਕਰ ਸਕਦੇ ਹੋ। ਹੁਣ ਸਾਨੂੰ constant ਦਿੱਤੇ ਹੋਏ ਆ, so we have to put these constant in our equation and then we have to find out the binding energy ਜਿਹੜੀ ਆ ਉਹ ਕਿਹੜਾ ਨਿਊਕਲੀਅਸ ਹੋਏਗਾ 125 वाला, which is the most stable nucleus. So binding energy is AVA minus asymmetry 2 by 3 minus Coulomb energy ZZ minus 1 over A1 over 3 minus asymmetry energy A minus 2Z square over A plus minus pairing energy over A3 by 4. So again curly by curly z is equal to 0 to find out the most stable isobar. So this first term get 0, second goes to 0 and third term AC z square जेड़ा है उदी वैल्यू आ जाएगी 2z minus of 1 over A1 by 3 plus asymmetry term. So this comes out to be 2A minus 2Z over A. So minus and minus this get plus time 2, that is equal to 0. So we can write this equation as minus 2 AC over A1 by 3 plus AC over A1 by 3 plus 4 asymmetric minus A times asymmetric over A times Z, that is equal to 0. So solving for this, so what we get, Z is equal to 4 times asymmetric term plus A coulomb over A1 by 3 over 2 times AC over A1 by 3 plus A times asymmetric term over A. So if I multiply and divide this with A over A in order so that they can get easily cancelled, so this equation becomes A plus Coulomb energy times A over 4 asymmetric over 2 plus AC over 2 times asymmetric into 2 A the power 2 by 3. ਹੁਣ A ਸਾਨੂੰ ਜਿਹੜਾ ਦਿੱਤਾ ਹੋਇਆ that is equal to 125, Coulomb energy ਜਿਹੜੀ ਦਿੱਤੀ ਹੋਈ that is equal to 0.7 mega electron volt and asymmetric constant ਜਿਹੜਾ ਹੈ that is equal to 22.5 mega electron volt. So putting these values in this equation, so from that we can find out the value of Z. So 125 plus 0.7 into 1. So what is given? 125 over 4 into 22.5 over 2 plus 0.7 over 2 into 22.5 into 125 the power 2 by 3. Okay. So when we solve this, so this comes out to be 125 plus 0.01 over 2 plus 0.39. So Z comes out to be 52.30, and from there we can find the value of Z. So that is equal to atomic number 52. So from the given answers, so 52 ਜਿਹੜਾ ਆ ਉਹ ਕਿਹਦੇ ਚ ਦਿੱਤਾ ਹੋਇਆ ਸਾਨੂੰ, that is 52 tellurium 125. So option C is the correct option for this. So what I want to say in this today's lecture कि ਜਿਹੜਾ ਇਹ liquid drop model ਜਾਂ ਜਿਹੜਾ semi empirical mass formula ਉਹਦੀ derivation ਜਿਹੜੀ ਆ ਉਹ ਇੰਨੀ ਜ਼ਿਆਦਾ ਨਹੀਂ ਇੰਪੋਰਟੈਂਟ ਜਿੰਨੀ ਕਿ ਜਿਹੜੀ ਉਹਦੇ ਨਾਲ ਰਿਲੇਟਡ ਜਿਹੜੇ ਆ ਮਾਸ ਪੈਰਾਬੋਲਾ ਦੇ ਜਿਹੜੇ ਕੁਐਸਚਨ ਆ in order to find the most stable isobar. So there are many such questions which come from this semi-empirical mass formula. So numerical ਜਿਹੜੇ ਆ ਉਹ ਇਸ ਟੌਪਿਕ ਦੇ ਕਾਫੀ ਇੰਪੋਰਟੈਂਟ ਆ. So ਅਗਲੇ ਆਪਾਂ ਇਸ ਲੈਕਚਰ ਦੇ ਵਿੱਚ ਜਿਹੜਾ ਆ the other applications of liquid drop model, that is the nuclear fission and how we can find out which nucleus which is undergoing a spontaneous nuclear fission or it is undergoing a sustained reaction. So till then, goodbye. So see you in the next lecture. So you can also mark your attendance in the comment box, or if you have any problem you can ask in the comment box. Okay dear students, goodbye. So ਇਹ ਜਿਹੜੇ notes ਆ ਅੱਜ ਦੇ I will send you on your WhatsApp group.